Hello again, and welcome to another lecture in CIT 130, Beginning Java. Today we're going to talk a little bit about arrays. Now, I imagine you have all seen the idea of an array in your Introduction to Programming class. But I just want to go over it from a Java perspective, show you some of the things you can do with it from a practical programming perspective, and just refresh your memory on how they work. An array is really it's a data structure that is a list of values of a specified type. When we create an array, we create it based on a particular data type. For instance, we might say int grades and make that some kind of array. But what is the syntax when we declare that array? On the left-hand side, we, just like any other declaration for a variable, we have the type and the name. To indicate that it's going to be an array, we use square brackets. Either we can do those square brackets on the data type, or we can do them on the name of the array, or the variable name. Customarily, you'll see most people put them on the data type, and one of the reasons that is because on the right side we declare it similar to objects, because technically an array is a reference type like those made from classes, and we will say new int, and then we have the square brackets there. Typically, we're going to put some size for the array in there. Like, let's say there were 10 people in the class, so we were going to have 10 grades. We would declare it like that. So we have the type with square brackets indicating an array. We have the user-defined name. Then we use the new keyword, the type again with the square brackets and the size of the array. Now we're going to talk about, when we declare an array like this, how to fill it with values when we go into our example. There is also a way to sort of quick create an array by filling it with values. If I say int array grades equals 92, 89, 94, 91, 77, 95, 96. We've made an array that has 7 values in it. So it is an array of size 7, not 10 in this case. And these are the values inside of that array. Now, how does that work conceptually? From a concept point, if we think of a variable, if we do int grade equals 90, we can think of grade as the address that points to sort of a house that holds the value 90 in it. So the variable name is the address, and it points to like a house, a holding space inside of memory with the value in it. Whereas when we do int array grades equals new int 10, whoops, we can think of grades as the address to more like an apartment building. So if we have a set of values in there, like 90, 92, 89, 94, 91, 77, 95, 96. We'll fill in a full 10. I should think that should be 8 there. 84, 88. I think that's 10. But I think you get the idea. These are a series of apartments in an apartment building that would be at the address grades. Each of these apartments has an apartment number. This is called an index. So what we typically have is starting with 0 and incrementing by 1 for each index is an apartment number 0 through 9 in this case, where the final address is one less than the length or number of apartments, number of containers in the array list. So 0 is the first, and we talked about this a little bit when we talked about strings a couple of lectures ago. The first value is in 0, the last value is in length minus 1. And we call these apartment numbers indexes. And they'll become very important when we start working on putting values in and taking values out of the array. So hopefully, from a conceptual standpoint, what I've just discussed is something that you are already familiar with, you're already comfortable with because you worked with it in your introduction to programming class before. So to see it in practice, let's go back to one of our versions of the movie tickets application. And let's look at that and see something we can do with it. So taking a look at this, imagine if instead of tallying the total as we go along, we want to store each of the ticket prices in its own slot in an array so that we can both tally the costs or look at the ticket for a given individual, the price for a given individual. So since prices are doubles, we'll go ahead and do a double array using the square brackets to indicate that it's an array of doubles. We'll call it prices, and we'll make it a new double array, and I'm going to make the size 100. Now, one of the things that is important to understand in Java This is something that's unique to Java or nearly unique to Java because we don't have typical memory management like we would in a language like C or C++. We cannot resize arrays once we create them. So that is a sort of disadvantage in Java, but with common memory sizes in today's computers, it's generally doesn't tend to be a big deal. And if you join us next semester for the advanced Java, you'll learn about using other data structures where we can do some special stuff to resize for larger data sets. So what is typical to do in Java is to size the array at some upper bound, something larger than you believe you would ever need to use. We'll say that 100 is an upper bound. Maybe no theater has more than 100 seats in it, so nobody could ever buy more than 100 tickets for the same movie, so we make that our upper bound. That will suffice for us to be able to work with this here. So now what we've created is an apartment building where we have 100 different boxes or apartments, each with a value of 0.0 in them. When we create the array without any values, we have indexes 0 through 99, since it's an array of length 100. But when we initialize, or when we create it without initializing it with any values like we did up here, they would all hold a value of 0.0, as would any numeric data type. So now that we have that there, we could now go ahead and start putting the prices inside of each of the apartments. So I'm going to get rid of the plus equals on each of these. And what we're going to do is refer to the index where we want to store the price. Well, the index has to be the appropriate index based on which customer they are, or which person in the customer's group they are. So as they ask for each of the people, we're gonna store them inside of the index. For this version, it's going to make more sense to start with 0, stay less than the party size, and do the increment version, because that allows us to easily go ahead and store those at the index of X. Prices, and we say the term, when we read this, we say prices sub X. That's how we read an index in with an array. So we would say prices sub X equals 5.5, or prices sub X equals 6.5, or prices sub X equals 7.5. And X is going to increment every time through. So the first person will go in index 0, the second in index 1, and so on and so forth. Now going back to that idea that where we upper bound our array, typically in nearly all cases, probably more than 99 times out of 100, no one's going to get even near to this 100 size. So really, we're only using a small subsection of the array, But that's okay. That's not something to worry about. So after we go through the entire party size, we'll have stored in each of those apartments or indexes one of the values. We can create a separate for loop now. And I mentioned this before, but because of our scope rules, this int x only is valid from, from this point here, from this point here through the end of that for loop. Then that variable doesn't exist anymore. So when I do int x down here and say it equals 0, and we check for x is less than party size, what we're dealing with there will loop back through the entire array. And what we can do is we can do the price plus equals prices sub x. Now, from a practical standpoint, you're saying, this feels a little strange. All we did was populate it and then loop through it to Adam. Why would we do that? Imagine or think about a much larger scale application where we may be storing each of the ticket prices in its own array place so that we could go back and audit them. Or if somebody was like, what did we charge for this person again? Oh, they were number 3, so I look in the array at spot 2 and say, oh, that was 650 or whatever. So imagine, that kind of practicality. We're not going to build that all in and add a lot of overhead to make it more practical, but just think in those terms that's kind of how this works. So now that will add up the prices, and we'll still print that the way we were printing it before. So as each person's age is taken in, we're going to record a price for that person's ticket, and we're going to record it in each one in the next consecutive index within the array. Once they're all recorded, we can go back through that entire array and add up the values to get our total cost and print that out. Let's see how that works. I save movie tickets. We'll go out here and we'll do javac movietickets.java, and we will run the application. How many people are in your party? We'll just do 3 for now. So what this is doing, it's asking me how old the person for the ticket is. We're going to go with a 9-year-old. And what it did at that point was it checked that age. It was less than 12, and it stored in prices sub 0 5.5. So now when it asks the age of the next person, and I say 49, what that does is it checks the age, finds out that it's greater than 12 and less than 55, and it stores in prices sub 1 750. Now it's prices sub 1 because we're in this for loop. X started at 0. When it looped back around to ask for the next, how old the next person was, X was now 1. It incremented on the way back around. It's going to ask the final person. We'll say it's 77. We'll hit enter, and we'll get a total cost of $19.50. When it added the 77, Remember, it had looped back around. X was now 2. It checked the age, found it to be greater than 55, stored the 650 in index 2, and then because party size was 3, when it loops back around and X becomes 3, X is no longer less than party size. I want to talk about, before moving on, I want to talk about one other property of arrays here. In theory, I could do prices dot length here. Now, unlike a string with arrays, the length does not have the parentheses. It just is prices dot length. We'll talk a little more about that when we do object-oriented stuff, which we'll start in the next lecture. And we'll talk about how something can, when the parentheses are there and when they're not, and what we call all that stuff. In this case, that'll be okay, because what will happen now is this will loop 100 times, but remember, any of the empty apartments or places where we don't put in other values will have 0 in them. So when I do prices.length, I'll loop 100 times, but it'll just start adding zeros after the party is completed. So let's take a look, and we'll see that that doesn't cause any issues. The program will run identically. Technically, from a purely computational, I put in 9, I don't want it that large. From a purely computational size, this would technically run slower, but you'll notice on most modern PCs something where we're looping, whether it's 3 times or 100 times, we're not going to be able to notice that difference. The loop time is much, much, much too fast for us to be able to detect the difference. And you'll see that the price is the same. But there's another thing that I want to look at here. So let's say we weren't sure, do I do less than or less than or equal to? There is a really important concept in arrays about these indexes. Just as if we were trying to find a person's apartment and we started going through the building and we were looking for apartment number 100, when the largest apartment number is 99, we wouldn't find it. That's what will happen here, but let's take a look at how that plays itself out on this side. So if I recompile, it compiles fine, because the compiler simply looks at the fact that this is a for loop header. I can do this just fine. These are all valid statements. I can declare the new variable because the old x is out of scope. I can check that x against anything I want, including the length of the prices array, and I can increment it once per time. And I can add something out of the array to the price variable as I go through there, and it doesn't have the intelligence or to put 2 and 2 together and determine that this is going to go to a value too large for this. That's going to happen at runtime. This is considered like a logic error or a bad design error on the programmer's part. So let's see how that works. when I go in and run it again, it'll start just fine. I'll say there are 3 people in the party. They're going to be 9, 49, and 77 as they were above. But when I run it, we now get this error that says exception in thread main java.lang.array index out of bounds exception. Now we're going to talk about what exceptions are later on this semester. It's one of the last things we cover. But what we see is that index 100 is out of bounds for a length of 100, because remember it starts at 0. So we need to be careful and always stay under that length. That's a very important thing with arrays. Now, there's one more practical programming thing that I want to share with you when working with arrays in this particular example. So what we're going to do is we're going to introduce sort of an outer non-deterministic loop. We're going to do another do loop. And so I need to indent everything here by 1, tab, end, and we're going to do that while not closed, and we'll go up and create the variable in just a minute. Forgot to put my closing curly bracket for the do loop. And what we'll do here is we'll do a system.out.print, and we'll say, is the theater closed, to allow the person to type in the Y or N. And what we're going to do is we're going to check and see. We'll do the keyboard.next. We'll keep this simple at this point. I don't want to get too wrapped up in too many things. So we'll just take next, assume it is that it is a single word of like yes, yeah, yep, yeah, or just Y. And then we will check the car at for that. Let's go ahead and actually put it in a closed YN variable that we'll have to create. So let's move this, Control X, put it right there, and then we'll say if closed YN dot car at 0 equals Y, or closed YN dot car at 0 equals Y. If that's the case, closed equals true, else closed equals false. So all I'm doing here is just if they say the theater's closed, then it'll be, then not closed will be false, because the true for closed will become false here, and we'll drop out of the loop. And I just realized I put this in the wrong place. because I have to print out each person's price as it comes. So if it's so we want to move this up is really what we want to do. Just misplaced my close of my loop. So it's going to go through, get all the prices like it did before, do the total. Then it's just going to find out if we're closed or not. And if we're not closed, it's going to go back around. So all I've done is added an outer loop, or I've nested a loop inside of a loop. This is very common in programming. So what I've done is I've created a do loop to loop as long as the theater's open. Here's one loop to determine or to make sure that they enter in a number for the party. Then here's another deterministic loop that determines the prices for the prices for each person in the party. Then we total the cost in even another loop. Then we print out the price, find out if we're closed, and then that outer do while loop loops back around. I'm doing this for a very specific reason because I want to show you something important. There's always a method to my madness. So let's go back, recompile. I made a mistake because, as I had indicated, I needed to declare those variables, and I clearly forgot. So since we already have that, we'll add the closed yn variable in here as a string, and we'll create a Boolean closed variable here. So let's go ahead and recompile. Hopefully that was my only mistake, and indeed it was. So now let's run through it. Java movie tickets. We'll say there are 3 in the party. We'll do the one person who's 9, the next person who's 49, and the third person who's 47 or 77, and we'll get the 1950 again. Now it asks, is the theater closed? If I say no, what it'll do is it'll loop back around. Let's say this time there are 2 in the party, and it's going to be 2 adults. Let's just say it's 2 people out on a date. And so the person for this first ticket is 22. The person for the second ticket is 20. So my total price should be $15. But what you'll notice here is I wound up with a larger price than that. In fact, a much larger price than that. And there are 2 reasons for that. The first is that this price never resets. So what I need to do is at the top of the loop is I need to say price equals 0.0. So what that's going to do is every time I have a new set of people, it's going to reset that that number. We'll say yes, so I can recompile, and you can see that that's going to help us out, but only some, because there's an important other concept I want to show here. 77, we get the 1950. The theater is not closed. The second one is 2 people. We'll do the 22 and 20. And we'll see that it's coming out 2150 when it should have been 15. Let's talk about why. So, when we created this prices array, it created this space where it was lots of zeros. Where indexes are 0, 1, 2, 3, 4, 5, 6, so on until 99. And what happened was, with the first one, we had the child ticket. Whoops. We had the adult ticket. And we had the senior citizen ticket. And then there were zeros filled in the rest of them all the way through the end. So the first time it came through, it added the 5.5 to the 7.5, getting 13, plus 6.5 is 1950, which is the right answer. Now, the second time through the loop, when there are only two people, when it asks the age of the first person and they're 22, it stores in index 0 the 7.5. It replaces the 5.5 that's already there with the 7.5. When the second person is indicated as being 20, the 7.5 gets replaced again by 7.5. But now we don't loop anymore, so the third apartment or third index still has the 6.5 stored there, which is why we got 2150. So much like I had to zero out my prices when I looped back around to the top, my price, so that I wouldn't add the original 1950 to the second person's 2150 that was supposed to be 15. We also have to clear the loop. I am going to do that at the bottom, mostly just to show you things as from an efficiency standpoint. Like I said, technically, technically by going to the end here, the length, I'm creating an inefficiency, but I did that so I could show you both the length and the index issue. But once I've added up the price here, what I can do is I can actually loop one more time through the array, but just do it at party size. And set prices sub x equal to 0.0, which will take any value out of the array to reinitialize it. Now, again, going back to our theoretical, more complex example where we're not filling in those details, we would have stored that off somewhere, and we will learn about writing to files later in the semester. So there's a way we could, like, say, dump all those prices to a file for the daily counts or something like that. Or again, if you join us for CIT 230, we'll show you how to work against databases, where you could store this into actually a relational database and hold the information there to be used or worked with at a future time. So what I've done here is I've zeroed out all those apartments so that the next time through, these all would have 0.0 in them, so that when I went in and did a ticket for 750 followed by a ticket for 750, that 6.5 was gotten rid of beforehand, so we don't have to worry about it. And let me prove that to you. The theater is closed. Let's recompile. And let's run our example. The 3-person party, which had a 9-year-old, a 49-year-old, and a 77-year-old for a total of 1950. And the second one with a 22-year-old and a 20-year-old. Whoops. Dang it, I keep doing that. Again, if you don't remember from previous lectures, Control-C will terminate the program. So that I can rerun it. Sometimes when I'm talking, my mouth gets ahead of my brain. So this one is going to have the 2-person party with a 22-year-old and a 20-year-old. Now we get the right price because we zeroed out all the indices or indexes as we went. So now we can say the theater is closed. So that gives us a set of basics to work with. But there are still a couple of things that I want to show you. So what I am going to do is I am going to do a save as here. And I'm going to call this one movie tickets array 1. I'm going to close this here. I'm going to go to that examples folder. And I'm going to do movie tickets non-deterministic. I'm going to rename that to movie tickets. Yes, I made a mistake because I did a save as. So let me delete this one. Yes. Because I saved it as array 1. And let's rename this one again. And we'll do movie tickets there. So it gets tricky. I could, in theory, have named each of these movie tickets programs inside the class files in these longer names. But I'm really trying to think of them as different versions of the exact same program. So I wanted to use the same name. So I am creating a slightly more complex situation for myself, switching between them. But that's okay. Let's go ahead and open it up so that we can do something else. I want to show another way, or I want to show another concept that has to do with our incrementing and decrementing operators that the arrays really lend themselves to this. So we're going to do that now. So what I'm going to do here is going to create the double array prices, just like we did before. It's going to be a new double array of size 100. Nothing different than we did before. But what we're going to do here is, now that this is the do while loop, what we're going to do is we're going to do, if we want to do this prices array, and I'm kind of doing it in 2 steps here, I'm going to have to put something in the square brackets, but I don't have the X anymore. So how do I know where I'm at? Well, I have, what I can do is I can create an index variable that that we initialize to 0. And now what we can do is we can do prices sub index. Now we figured out where we're going to put it. And then it'll ask if they need more tickets. If it's yes, they'll go back around. But the problem is index hasn't changed. But remember, just like we do the x plus plus, we can do index plus plus. Now I put it on all three. It will only one of these will fire each time we go through the loop. So we won't increase the index 3 times each time through the loop. It won't go from 0 to 2 to 5 to 7 or to 8, etc., etc. It's not going to add 3 every time. Because only one of these is going to be true in each of the loops. So we've set that up, and this is a way of, during a non-deterministic loop, to keep track of that total cost. So let's see that in action, and then I want to talk about something else with these increment and decrement operators. That's an important part of Java. So the first person is 9. There's more tickets. The second person is 49. Yes, there's more tickets. It's 77. And no, there are no more tickets. Oh, we got the 0.0 because I forgot to loop through the loop and add it all up. That was my just an oversight on my part. We will do that with the deterministic loop for int x equals 0. X is less than. What we can do in this case is we can say that it is less than index because we've been counting the whole time. We increment the last time when we say no. So really what we've done now is we've technically stored the party size inside of the index variable because it's one more than the highest index. Since the first index is 0, the last index is 1 minus the length or party size in this case. We're in good shape. So that's a really valuable way to find out where we're at. Note that index has to be declared at a level outside of this do loop here to be used in this for loop down here. Because if it was used, or if it was declared inside this do loop, it wouldn't live past it. So in order to have access to that index, we had to declare it above. It's one of the many reasons you'll see that we typically declare all our variables at the top of anything, unless they're localized like a for loop index. So now we can just say price plus equals prices sub x. Remember, it's x this time. We're in the deterministic loop. Index was keeping track of the full thing. We will save that. Let's recompile and go through our example again. And this time it should add up to the proper price, which I believe it'll be $19.50. So we're good there. So in addition to being able to increment like this, we can put the incrementing on the front end. Whoops. Out of place there. And this is what is called pre-indexing instead of post-indexing. So what we're really dealing with in this case is incrementing our index before storing the value. So what that would do if we do it this way is, in that first example, and let's put them back to zeros, pretending as if we just started the program. When we pre-increment, what would happen is it would store the value for the 9-year-old here, then but then it's still here when it looped back around. Then it pre-increments and puts the 750 here, stays, loops back around, pre-increments and puts the 650 in here. But we need to be careful whether we want to pre-increment or post-increment. In this case, post-increment is safer. By skipping over that first apartment or first index, what we wind up doing is we use it in our adding, and that could cause some problems. We will be able to see that as a problem, because if we recompile with the pre-increment, what we see is the 9, yes, 49, yes, 77, no. You'll notice that our ticket price is 13. We got away with the older person getting no ticket. Going back to our picture here, the reason is it pre-incremented, so it went from 0 to 1, then stored, went from 1 to 2, then stored, went from 2 to 3, then stored, then it dropped out. So index is 3, but because we expect our answers to be in 0, 1, and 2, what we find is we're actually adding the 0 and the first 2 prices because we pre-incremented. So there are places where that can be valuable, but this is not one of them. So I want you to be aware of the pre and post incrementing and decrementing, but in this case, post is the right answer. So if I go back, resave it again, recompile it, re-go through our example, 9, yes, 49, yes, 77, yes. Darn it. I didn't mean to say yes. So I'll just put in that, say no. This time it'll be $25 because I put in an extra person. But you'll see that it works. It didn't cut off that last price because we're now post-indexing. Hopefully that makes sense to everyone, and you can use that in your own applications to help with things. Now I want to look at one more thing before we get out of here. So we had age up here as an integer. Let's add an ages array. And what we're going to do is in here, we're going to store in ages sub index the current age. And I want to talk about something in line with that. If I do system.out.printf, and we do the customer with age %d was charged %.2f %n, comma, ages sub x, comma, prices sub x. Just adding in the ages, storing the age and the price each time. You'll notice I did not increment index here because I want it to stay at the same place until after I also store the price. I'm going to explain exactly why that is in just a second. Let's recompile. I made a mistake. This says array required. Did I not declare ages properly? I did not. Somehow I got talking and did not declare it right. It's a new int array. And I'm making it the same size. And again, I'll explain that in more detail in just a minute. Let's go back, recompile. I should have fixed my mistake. How old is the person for this ticket? They're 9. Yes, there's more. It's 49. Yes, there's more. It's 77. No, there's no more. We get our 1950, but you'll see that the customer with age 9 was charged $550, the customer with age 49 was charged $750, and the customer with age 77 was charged $650. What we've done is we've created a pairing of our arrays. So what I've done is, let's imagine down here the array ages, which starts with 0, 0, 0, 0, 0, 0, dot, 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 and goes to the final 0. And this has the indexes 0, 1, 2, 3, 4, 5, 6, just like above. And I noticed when I did this, I need to space that out. Let's go back and put in our 0.0s because I want to run through the example in detail again. And our last one is 99. So what I'm intentionally doing here is I'm creating a relationship simply based on index between the prices and the ages. These are two different data structures, two different lists of values of even two different data types, but by always stepping through both when we fill it and when we retrieve from it at the same index, we're making an association between the price at index 0 and the age in the other array at index 0. Because I don't increment until after I do the price, the first time through, the first age gets stored at 0, index is still 0. That 9 is less than 12. I store 5.5 at 0, then increment, post increment being very important here, especially now that they're related, and then go back around. Index was 1, so we store the next age, 49, at 1. Index stays 1 until we get down here and see that 49 is between 12 and 55. Store, post increment, store 750 at 1, and then increment to 2. We come back around, get that age of 77, and that the index still stays 2 until we go down here and find 77 greater than 55. The index increases, and we store the 6.5, then we increase the index to 3. Now when we come down here, because we stored the age at the same index as the corresponding price, we have that relationship. So what happens is the first time through, we store the age of 9 in index 0, and then the price of 5.5 at 0 and increment. Then the second time through, we go to 49, store, but we don't increase index till after we store 7.5. The third time through, we go 77 and put in the 6.5, and then we increment index, so index is 3, but when we say no, it drops out. We've created a relationship through index number between the two values. It's as if we're creating almost some kind of complex data structure that associates things with two different arrays with two different types, but they have a related value. So there's one more thing we want to see in doing this. So we see our for loop here, like we've been doing. In Java, there is also something called an enhanced for loop. So there's another kind of for loop where what we can do is we can do double P, meaning kind of price, and the prices array. This is something called an enhanced for loop. I'll say which reads for each P in array prices do. And what we'll do here is change this to P. So what we're doing is basically go through the entire prices loop and grab each value and store it temporarily in P. It creates a very concise formatting. Price P is stored in P, then we add it, go to the next one, go to the next one, and we hold on to them. But in this case, we lost our X, but we can just throw it in right above the loop. We can just say int X equals 0. And do X plus plus on the second one so that we see the age and the price first at 0, then 1, 2, 3, 4, 5. This is independent of what's happening in this for loop. But that's just to show you something. In reality, I technically don't need either of these for the way the program runs. I was just showing you how how we paired the arrays. If I get rid of that, how old is the person for this ticket? They're 9, yes. 49, yes. 77, no. We get the 1950. But what happened in this case was each time through the enhanced for loop, it took the next value here, temporarily stored it in P, added it there, and went back. It gets rid of the need for the index when we're just cycling through every value in the array, the for each loop. This is a thing that you may have seen, particularly if you're taking or have taken a Visual Basic class. The for each loop is common there, and it's in a lot of languages because cycling through all values within an array is a common practice. So I just wanted to show that as an alternative operation. So just in review, what we talked about today was arrays. We talked about how each array is based on a certain data type, that we must create our array at a specific size, and we cannot change that size. We can just declare it as a size and use loops like we did in our examples today to fill in the values. Or we can also list those values inside of curly brackets if that's what we're looking to do. We talked about the difference between a variable holding a single value and an array which holds multiple values where each value has an index associated with it. Kind of the difference between a house and an apartment complex. We talked about associating the values at the same index of two different arrays for the sake of being able to store different data types but that are associated with each other. You could do the same thing with strings of student names and ints or doubles of grades, where we could say, student Brian had the 90 and student, Joe had the 92, etc., etc. That kind of thing. And then we finished up with our for each loop, or our enhanced for loop as they call it in Java, where we did each value in this array. So note that this data type has to match the data type stored in this array. For each local variable in this array, do some operation. That was the final thing we looked at. So this gives you a pretty good overview, a pretty good look at arrays in general. The next homework will be posted shortly after this video, which will allow you to practice creating your own method and working with arrays. And if you have any questions or any of this doesn't make sense to you, please reach out to me, and we'll work it through together. Take care and talk to you soon.